Well, V is the volume of the column of fluid, right? So if this was height H, and this is surface area A, so V is the volume, so V is just A times H, right? So you're left with rho V over, so the volume is equal to A times H. So divided by A, you just get H. This is the most common equation that you see in most textbooks. So a lot of times it might be interchanged, written like this, rho GH. So density at the bottom is equal to density at the top plus rho GH. Now you could work this one backwards. So in other words, this could be, for example, representing water. So if I want to know the pressure, let's say the pressure at the top of the water is atmospheric pressure. If I want to know the pressure at the bottom, let's say this is a certain kind of swimming pool. You know, it's a swimming pool. So if I wanted to know what's the pressure at the bottom of a swimming pool, I would use this equation. P0 would be P atmosphere. Okay. And then the rho would be the density of water, and then I would do GH, and then this would give me rho, pressure at the bottom of a swimming pool, or the pressure at the bottom of the ocean. Okay. Or I could do it differently. I could say this column of air is the air, and this is gonna be the pressure atmospheric. So we live here. So let's say I live here, right? And if I want to know what's the pressure up there, so if I went up there, so imagine this was a certain mountain, you know. So let's say I go to the top of Big Bear, and I want to know what is the pressure there. Well, it's going to be less pressure, right? You're going to be able to boil eggs more easily because there's less air pressure there. So what is going to be the pressure if I know the height? Well, this now, P atmosphere will now be P bottom, you see? Because now it's at the bottom of the fluid. So P atmosphere was at the top of the water. And I want to know what's the bottom of pressure of the water. And now P atmosphere is the bottom. And then the P top, right, is like your P0. Okay, so for example, if I wanted to know what is the pressure at the top of, let's say, Big Bear. Now, for the purposes of this example, let's assume the density of air is pretty much constant from here to Big Bear. The density of air, let's say, doesn't change too much, which it really does, but let's just say it doesn't. So the pressure at the bottom would be 1.013 times 10 to the 5th. Okay. When you do these kinds of problems, try to do them all in the regular SI matrix system. Okay. The pressure at the top, we don't know. Okay. Plus the density of air, which we got was 1.29. G, of course, we're going to assume G is more or less constant, but we learned in the last chapter that it actually gets less as you go away, right? But it's more or less constant within, up to the, if you go to the outer space, you know. So that's going to be 9.8. So what's the height of Big Bear? So isn't it about, let's say, 6,000 feet high? Roughly. I'm doing just a rough measurement. The height is about 6,000 feet. If your Big Bear is basically a mountain here, Big Bear Lake is about 6,000 feet, and then some parts of it, Big Bear City, is a little bit more like 7,000 feet. So roughly speaking, if you divide that, the conversion between meter and feet is about 3. So roughly it's about 2,000 meters. So I'm doing a ballpark estimate here. So every 3 feet is about 1 meter. Okay, so if you put 2,000 for the height here, so now to calculate P top, you take all this stuff, you bring it over here, and let's calculate that. Here's my calculator. 1.013 times 10 to the power 5 minus 1.29 times 9.8 times 2,000. 76. So P top of the mountain is equal to 76. Okay, and that's pascals. 76,016 pascals, or if you wanted to do it, 76.016 kilopascal. Now, it would be more interesting to say how many atmospheres is that. So you would divide that P top by 1 atmosphere, which is the pressure at the bottom of the of that column. So you would go 76.016 divided by 101.3. So divided by 101,300. 101,300. 0.75, okay? Atmospheres. So the pressure at the top of roughly where Big Bear is at the top of the mountain would be 0.75 atmospheres. But that's only approximate, okay? Next week I'll show you what would happen. How would we get the pressure if the density varies as a function of height? So we'll do that kind of stuff, okay?